Section 5.2 is about trigonometric functions, and we're going to use the unit circle in order to better understand them. So here I have a unit circle, right? Our formula for the unit circle is x squared plus y squared equals 1. And we learned in our last section that arc length S equals r theta, right? The radius times theta, which is just going to really be theta in this case because our radius is 1. Let's let T be a line whose length is S units. And that way when we wrap it around our circle, they have the same length. Notice that T can take on, the length is always going to be positive, but it can take on negative values as well. Let's go ahead and define our trigonometric functions. The sine function associates our t with the y-coordinate of p and is denoted sine of t equals y. This is the stuff we're going to have to remember. Sine of t is y. Our cosine function is sine of t is x. Our tangent function is y over x, and x can't be 0, right? Because then we'll be dividing by 0, which nobody likes in math. We break all of math. The cosecant function is 1 over y when y doesn't equal 0. The secant function is 1 over x when x doesn't equal 0. And our cotangent function is x over y as long as y doesn't equal 0. So these are our functions. So here we have our 6 trigonometric functions all together in one spot so you can see them. These all come from our trigonometric ratios that we learned in geometry, right? If I put a triangle on here, sine is opposite over hypotenuse. Well, our hypotenuse now is always 1, right? Because we're on the unit circle. So sine is going to be whatever this height is, which is our x value, right, over 1, which is just x. Cosine is going to be the adjacent. That's going to be this. That's going to give us our, y. This is our y value. Cosine is going to give us our x, right? We've got our adjacent. That's our x value over 1. And tangent, that would be our opposite over our adjacent, which is our x value over our y value. Y value over our x value. So let's let t be a real number and the point on our unit circle associated with t be -1/2 square root of 3 over 2. Sine of t is y. So here's my x, here's my y. That means sine of t is going to be the square root of 3 over 2. Cosine of t is x, so x is going to be -1/2. Tangent of t is going to be y over x, so I've got the square root of 3 over 2 over -1/2. That's going to give me the square root of 3 over 2 times -2 over 1, which will simplify to negative square root of 3. For cosecant, that's 1 over y, so I have 1 over the square root of 3 over 2. That gives me 2 over the square root of 3, but we don't like radicals in our denominator, right? We need to rationalize those denominators. So we're going to multiply by square root of 3 on the top and the bottom. So I get 2 square root of 3 over 3. If I take the secant of t, that is 1 over x. So I'm going to take 1 over -1/2. That's going to give me a -2. And last but not least, cotangent. I'm going to take x over y. So I have -1/2 times 2 over the square root of 3. My 2's cancel. -1 square root of 3, but we don't like that. So we multiply the square root of 3 on the top and the bottom. So I have negative square root of 3 over 3. So that's our first example of finding values given a point on the circle. And it may have been helpful to see, right, this is our t, the arc length of my x and y value. That's where our point is in the second quadrant. Remember, it has 4 quadrants, the coordinate plane. numbered 1 through 4 and labeled counterclockwise. Let's go through, so if theta was to equal t radians, then sine of theta would equal t, cosine of theta equals cosecant of t, cosine of theta equals t, secant of theta equals t, tangent of theta equals t, and cotangent of theta equals t. I'm not quite sure where all my thetas went, but we are substituting theta for t, right, where that's our angle, right? And that makes sense that our arc length would be the same because we're in the unit circle and s equals our theta and r is 1. So let's find the exact value of the 6 trigonometric functions of quadrantal angles. Remember that quadrantal angles are angles that their terminal rays, so I've got my initial ray, right? My terminal ray is on an x-axis. So there are only 4, right? We have 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So let's go ahead and find the 6 trigonometric functions for when I have the quadrantal angle of 0. So at 0, I have that the point x is 1, y is 0, so I've got x, y. Sine of theta is y, which is 0. Cosine of theta is x, which is 1. Tangent of theta is y over x, which is 0 over 1, which is just 0. That's okay. Then I have that cosecant, which is 1 of theta, is 1 over y. So I get 1 over 0. So that's actually going to be undefined, right? We can't divide by 0. Secant of theta, well, that's going to give me 1 over x, which is 1 over 1, so 1. And cotangent of theta equals x over y, which is 1 over 0, which is undefined. So theta of 0 is undefined when we've got a cosecant, is undefined has undefined cosecant and cotangent. So a theta of 0 degrees has undefined cosecant and cotangent. Let's clear the screen and make room for problem 2. So at 90 degrees, that's right here. At 90 degrees, I have the point when x is 0, y is 1. So sine of theta, which is 90, is going to be 1 because that's our y value. Cosine of theta is x, which is 0. Tangent of theta is y over x, which is 1 over 0, which is undefined. So tangent is undefined when theta is 90 degrees. Cosecant of theta is 1 over y, which is 1 over 1, which is 1. Secant of theta is 1 over x, which is 1 over 0, which is undefined. So we also have that secant is undefined when theta is 90 degrees. And then I have cotangent, which is x over y, which gives me 0 over 1, which is still 0, but is defined. So here's a table of our quadrantal angles, right? And where they aren't defined. So we had found that 0 was had cosecant was not defined and its cotangent was not defined. We did just find that at 90 degrees, which is pi over 2, tangent and secant were not defined, right? That's because our x value was 0. Let's take a look at pi and the 3 pi over 2.